Hello everyone, thanks for stopping in. Today we're going to be talking about Math 100, section 2.4, and this deals with applications of equations, which are frequently referred to as word problems, right? So first, let's talk about the procedure for solving word problems. The first step is read the problem. And you'll want to make sure you read carefully. The choice of words in the problem can help you determine how you're supposed to solve it. So make sure you're reading the problem carefully, right? Our second step is determine any knowns and unknowns for the question, right? We want to determine what we know and what is unknown. We want to determine those different things. Our third step is assign a variable to one of the unknowns. I need to assign a variable to one of the unknowns. I gotta pick a variable to use. Once I've chosen my variable, my fourth step is express all other unknowns using that variable. I express all other unknowns using that variable. These two steps go hand in hand. This is where you're assigning variable values to your unknown values. Now, step 5, once you've got some variables assigned, you write an equation representing the problem. Step 5 is where you write the equation representing the problem. This is where the reading part comes in handy, because many times the reading part helps you create your equation. The words themselves will tell you what the equation is supposed to be. Step 6 is solve the equation. Once you have an equation, you want to solve it, right? And we want to make sure we check. We want to check, right? We want to check that the answer makes sense. We want to check our answers, right? When writing, after we solve the equation, we want to check. And the seventh and final step of solving a word problem is to make sure we are answering the question. Make sure you answer the question. Sometimes you might need to do additional work after solving the equation to finish actually answering the question. Maybe you have to write a sentence. Maybe you need to compute another value. Make sure you're actually answering what the question is asking. So, now that we have our strategy, let's take a look at a bunch of examples. We're going to do a bunch of examples of word problems now. The first example says the product of 4 and a number decreased by 7 is 100. What is the number? There's only one unknown here, and that is the mystery number, right? So I'll let n's a good letter for a mystery number. N equal the number. N will be the number, right? Now I've read the problem. I've determined my knowns and my unknowns, right? The only thing I didn't know was the number. I knew everything else that was going on. I've assigned a variable. There were no other unknowns. Now I'm writing the equation. So let's look. The product of 4 and a number decreased by 7. Notice the comma. There's a pause there. And then the is. Is the equal sign. Equals 100. I know equals 100 is the right side, right? Now I'm going to look at the left side. I have a product. The product of 4, and this part is in its own group. It's in its own parentheses, right? It's separated by a comma, right? So I need to write a number decreased by 7 as its own group. I need to make sure I'm expressing this in terms of the group, right? It's a group. A number decreased by 7 is its own block. A number decreased by 7, right? Now I've written my equation, right? Now I need to solve the equation. Well, to solve this equation, we need to distribute. We get 4n minus 28 equals 100. Now that I've distributed, I want to balance the equation. To do that, I need to add 28 to both sides, because that will leave me with 4n equals 128. The last step, I got to divide by 4, right? Divide by 4 gives me n equals 128 divided by 4. I believe it's 27. Let's double check. Sorry, 32. Let's double check, though. Divided by 4. Oops. 128 divided by 4 is indeed 32. So the answer is 32. What is the number? The number is 32. So I solved the equation, and I answered the question. I should check, though. Does this make sense? A number decreased by 7. 32 decreased by 7, that's 25, right? If I multiply it by 4, that's 100. I know my answer makes sense. I can reread the question with my answer in mind to make sure it makes sense. So that's our first example. Now, we have a note. A note here. So, a note. Many times, writing the equation can be tricky. Make sure you practice translating the problems. That is the most important takeaway from this section, is that you can take a block of words and decipher it into the appropriate equation to solve the problem. That is what we are learning here. We already know how to solve equations, right? The new thing we're learning is how to write equations from word problems. So let's look at some more examples. At the 2014 Winter Olympics in Sochi, Russia, the U.S. won 13 more medals than France. I'm going to underline that. The U.S. won 13 more medals than France. The two countries won a combined total of 43 medals. How many medals did each country win? So, it might be handy for you to keep this list next to yourself. I'm going to keep it separate so I can refer to it as we need. We've read the problem. Now we want to determine any knowns and unknowns. I like to start with my unknowns. What don't I know? I don't know the U.S. medals, right? I don't know how many they won. I know they won 13 more than France, but I don't know how many the U.S. won. It doesn't tell me. I also don't know the French medals, right? I don't know how many medals France won either. And that's what I'm looking for, right? The question's asking me, how many medals did each country win? I know the total was 43. Combined, they won 43 medals, right? So those are my knowns and my unknowns, right? I didn't know the U.S. medals. I didn't know the French medals. But I did know the total. Now, assign a variable to one of the unknowns and express the other unknowns using that variable. I need to pick either the United States or France to be my variable. Let's look, though. The U.S. won 13 more medals than France. If I knew how much France won, if I knew the French medals, I could calculate the U.S. medals, right? I just need to go 13 more. So that's going to be my variable. I'm going to choose the French medals to be my variable. And I'm going to use the letter capital F. That's a good letter for French medals, right? You can use X if you want, but we can use the letters we want, right? Now, I have the French medals represented by capital F. I need to represent the U.S. medals using the letter F. Well, the question tells me whatever France won, the U.S. won 13 more than France did, right? France plus 13 is equal to the U.S. medals, right? French medals plus 13 is the U.S. That's what this sentence tells me. So I've now expressed all of my unknowns using the same variable, right? It's all in terms of F. I've used the letter F for everything. Now I need to write an equation representing this problem. I need to write an equation. Well, the total. To total something, I need to add, right? I need to add the U.S. plus France to equal the total. Well, the U.S. is represented by F plus 13, and France is represented by just F, and the total is 43, right? I didn't need these parentheses, but I put them in to remind myself that that whole chunk was for the US, right? So let's drop them out of there. F plus 13 plus F equals 43. Let's go to solve this equation. I notice right away on my left side, there are like terms to combine. F plus F is 2F, and we have plus 13, right, on the left, equals 43. I need to get F alone, so I'll subtract 13 from both sides. That's going to leave me with 2F equals 30. Now, to get rid of that 2 in front of the F, I divide by 2, and I divide by 2, right? Which tells me F is equal to 30 divided by 2 is 15. So France won 15 medals. France won 15 medals. Because F is 15, right? That's what the F tells me. Right? I've solved my equation. However, I need to answer the question. I need to finish answering the question. It wants to know how many medals did each country win. So I need the U.S. won. How many medals did the U.S. win? Well, if I know France won 15, it's 13 more, right? Using this equation here. 15 plus 13, which is 28, right? The U.S. must have won 28 medals. I can use the information in the question to answer my value. To answer the values, right? So, 15 and 28. Now, we should check. The U.S. won 13 more medals than France. It looks like that's true. The countries won a combined total of 43. Let's see, 15 plus 28, 43. I know I've done the question correctly because I reread it with my answer in mind. So we know we are correct. Now, let's look at another example. A lawn trimmer uses a mixture of gas and oil. You have to mix gas and oil and put it in your lawn trimmer. The mixture contains 16 ounces of gas for each 1 ounce of oil. So I know they are in relation to each other. For every 1 ounce of oil, I need 16 times as much gas, right? The tank holds 68 ounces. So let's see. I've got a relationship between gas and oil, and the tank holds, not folds, 16 ounces, or 68 ounces, right? How many ounces of oil and how many ounces of gas does it require when it is full? Well, let's take a look at our unknowns. We don't know the gas, we don't know the oil, but we do know the total, right? The total amount the tank holds, right? We have gas, oil, and the total size of the tank, right? The total tank, if we want to put the word tank here, the total for the tank is 68 ounces, right? Now, I need to choose one of my oil or gas to be my variable. Now, if I knew oil, gas is 16 times as much, right? If I know oil, I can find gas. It's 16 times as much. So I'm going to let X be my oil, and the amount of gas I need is 16 times as much, right? That's what this relationship tells me. Oil and gas are in a 16 to 1 ratio, right? 16x is equal to x, right? It needs to be those values, 16x and x. I have 16 times as much gas as I do oil. Now, how many ounces of oil and how many ounces of gas does it require when it's full? Well, to do this, I need to add, if I take my gas and I add my oil, that should give me the total in the tank, right? If I'm mixing gas and oil in my tank, I should be able to add them together to get the total, right? 16x plus x is, 17x, right? Equals 68. Now I need to divide by 17, right, to get x alone. Divide by 17, I get x equals 68 divided by 17 is 4. So I get x equals 4. So 4 ounces oil. How do I know it was 4 ounces oil? Because x is oil, and it's ounces, right? We're measuring things in ounces. Now for the gas. 16 times 4. Maybe I do some scratch work over here. 16 times 4, right? 16x is the gas. Well, that's 64, right? I did a little bit of scratch work down here in the corner. 16 times 4 is 64. So I know I have 64 ounces of gas. And right away, I have an idea that I've done it correctly, because 4 and 64 add up to be 68. That's how big my tank is. My numbers better add up to the size of the tank. Also, what's 4 times 16? It's 64. They're in the proper ratio to each other, right? It matches what the question said. You can always reread the question, re-look at the question, make sure your answers make sense. Always double check them, right? So that's an example with a lawn trimmer. How about an example of cutting some boards up? We're going to have a project involving some lumber. So a project calls for 3 pieces of wood, right? So I'm going to cut a board, right? I got a board, I'm going to cut it into 3 pieces, right? The longest piece, so I've got a longest piece, so I already know there's going to be a piece that's bigger than the rest, must be twice the middle-sized piece. So I have a long piece and a middle-sized piece. So I also know I'm probably going to have a shortest piece, right? I've got long, medium, and short, right? I've got 3 pieces of wood. The long one, the medium one, and the short one. The short piece must be 10 inches shorter than the middle-sized piece. If a board 70 inches long is used for the project, how long must each piece be? So I'm going to write my knowns and my unknowns. My unknowns, I have a long piece, a middle piece, and a short piece, right? I've got 3 pieces of my board I'm using. 3 pieces of my lumber, right? 3 pieces of board. And I also know the total size of the board, right? The board is 70 inches in total, right? The board has a total of 70 inches for its length, right? Now, I have read the problem. I've determined my knowns and my unknowns. I now need to assign a variable to one of the unknowns. I need to pick either the long piece, the mid piece, or the short piece. Whenever you have 3 variables, you need to figure out which of the 3 is the most useful to know first. Let's look. I have a sentence that relates the long piece to the middle piece. I also have a sentence that relates the short piece to the middle piece. Notice both sentences reference the middle-sized piece. That is going to be my x, because it is referenced twice. Both sentences reference that same variable. This will make things easier for myself to use the one that was doubly referenced. I'm going to choose the middle piece. Now, we've assigned a variable. We need to express the other unknowns using that variable. Here's where I use the sentences. I use the words. The longest piece is twice the middle piece. Well, so the long piece is 2x, right? It's twice as big as the middle, 2x. And then the short piece is 10 inches shorter than the middle. So the short piece must be x minus 10. It's 10 inches shorter, x minus 10. I take the middle piece and subtract 10. So I've used the relationary sentences to assign my variables. I've assigned some variables to my mix. Now, I'm on writing an equation. I need to write an equation using these. Well, I know the total size, so if I take the long piece's length, and I add the middle piece, and then I add the shortest piece, I should get the total length of the board, right? If I add all my pieces together, I should get the total length. Once again, these parentheses were not necessary, but I like to put parentheses whenever I have a group, just to keep myself organized. So I have 2x plus x plus x. That's 4x, right? And then I have a minus 10 equals 70. To get the x alone, I need to add 10 to both sides, right? Add 10 to both sides gives me 4x equals 70 plus 10 is 80. To get x alone, I need to divide by 4 as my last step, right? I divide by 4 and I get x equals 80 divided by 4 is 20. So I get 20 for my x. That means my board, I have one board That is 20 inches, right? The middle piece is 20 inches. How do I know it was inches? The question gave me the units, right? I'm measuring my board in inches. Now, it says how long must each piece be? I need to know what the long and short are as well. The long piece is twice the middle. Twice the middle. What's double 20? That'd be 40 inches, right? The longest piece is 40 inches. Finally, the short piece is 10 shorter than the middle, right? It's 10 shorter. So the short piece would be 10 inches. So my three boards will measure 40, 20, and 10 respectively, right? 40 for the longest, 20 for the middle, and 10 for the shortest. We should check. What do I get if I add up these numbers? 40 plus 20 plus 10 gives me 70, right? Similarly, I see these relationships are true. They're relationships in the question. The long piece is double the middle. The short piece is 10 shorter than the middle. I can double check my answers to make sure they're making sense, right? So here, we had three unknowns that were in relation with each other. Let's look at our next example. Lee Berry is reading a book and likes math puzzles. He opens his book and tells you that the 2 pages, right, he opens his book, he tells you the 2 pages he's looking at. The 2 pages that face each other have 301 as the sum of their page numbers. And we probably want to write that he's got 2 pages that face each other. What pages is he looking at? So when I open a book and have 2 pages, I've got a first page and a second page, right? So my unknowns are first page and second page. But I don't know what their page numbers are yet, right? But I do know the sum. The sum is 301. That is a known, right? That's one of my knowns. I have 2 unknowns and a known. Now, when I'm reading a book, how do pages that face each other relate? If I told you this was page 80, this would be page 81, right? If I said this was page 523, this would be page 524. They're always one apart, right? That's how page numbers work. So that'll help me find my relationship. When I assign a variable, if I let n be the first page, right? It's the first page here. The second page will be n plus 1 because it'll be 1 page bigger than whatever my left page is, right? It'll be 1 page bigger. N and n plus 1. Now, n and n plus 1 have a sum of 301. That's what the question tells me. So when I write my equation, I'll write n plus 1 equals 301. And I like to put parentheses around groups. You don't need them because they're not relevant. But let's take a look here. N plus 1. N plus n is 2n plus 1 equals 301. I got to get n alone, so I'll subtract 1 from both sides. You'll leave me with 2n equals 300, right? Divide by 2 tells me n is equal to 150. So what are my page numbers? What page numbers is he looking at? Well, the first page is 150, and 151 are the pages. How do I know 151 was the other one? Well, it's going to be 1 bigger, right? So these must be the pages they are looking at. 150 and 151. And do those sum to 301? Yep. So I know I have done the problem correctly. Now, let's look at a similar question that's a little more abstract. It says the lesser of 2 consecutive odd integers is doubled. The result is, that's my equal sign. Maybe I'll circle that right now. I know that's going to relate to an equal sign. 7 more than the greater of the 2 integers. 7 more than the greater of the integers. Find the 2 integers. So I have 2 unknowns. The lesser odd integer, right? I've got the lesser of the odd integers and the greater odd integer. And I know they're consecutive. Consecutive. back to back, right? The word consecutive means back to back. So I've got the lesser odd integer and the greater odd integer. Let's write some examples of consecutive odd integers. Let's see, 7 and 9, 81 and 83, 17 and 19, 23 and 25. Those are back-to-back odd numbers, right? 7, the next number would be 9, that's odd. 81, next would be 83. 17, next would be 19. 23, next would be 25. How far apart are all of these values? They're 2 apart, right? If I want to count odd integers, I count by 2's, right? Think about it. 1, 3, 5, 7, 9. Always a gap of 2, right? So that'll help me here. Because these are my unknowns, I'm going to choose the lesser to be n. And the greater will be n plus 2. Because it'll be 2 later than the lesser. They're always 2 apart, right? The lesser will be n, the greater will be n plus 2. This is just like the book example, right? We have things that are back to back. So I can relate them using the gap that will always exist, right? Books are always 1 page apart when you flip between pages, right? Always 1 page apart. Odd numbers are always 2 apart. If you go from one odd number to the next, it's a gap of 2. So I've assigned my variables. Now I need to write my equation. So what's it say? If the lesser is doubled, so I'll take the lesser integer and double it, right? 2 times the lesser is n. The result is 7 more than the greater. Well, the greater is n plus 2. And if I want 7 more than that, I need to add 7. Notice the parentheses help me here to make sure I keep my symbols consistent. The lesser is doubled, 2n. The result is 7 more than the greater. So I unpacked the words to get my equation. Now, on the right-hand side, I can clean things up a little bit, right? N plus 2 plus 7, I can drop these parentheses. It's all addition. And n, 2 and 7, like terms, combine to be 9. Now, I can get my n's all on one side. I'm going to subtract 1n here, right? Remember, n is 1n. Minus 1n here is going to give me 2 minus 1 is just n equals 9. So I get 9 and 11 are my integers. Now, it's good we got odd numbers, right? Oops, sorry, I was a little off page there. I subtracted 1n and got n equals 9. And so I said 9 and 11 are my integers. Those are my 2 values, right? I found the integers. It's good that they're odd, because the question says they're odd. If I got 4 and 6, I know I'm wrong. They have to be odd. It's also good that they're back to back. Now let's check. What's double the smaller? What's double 9? That's 18, right? What's 7 more than the bigger? That's also 18. So I know my answer is correct. I know these are the numbers I was looking for because I reread the problem to make sure. Now, let's look at another example. This time, it's a culinary example. We're going to be in the kitchen. Earlier this week, I made rice. The directions on the box called for 1.5 cups of liquid for every 1 cup of rice. So I have a relationship between liquid and rice. In his pantry, there was a box of vegetable stock that contained 4 cups. So 4 cups of vegetable stock. If Mr. Painter wants to use the entire box of vegetable stock for his rice, how much rice does he require? So this question is trying to get us to cook some rice. So let's take a look here. We need to determine our knowns and our unknowns. Well, we have liquids and rice. Those are the 2 values for my knowns and my unknowns, right? I have rice and liquid. And then I know something about the liquids later on, but I'm going to hold on that for a second. Because I'm looking for rice. The question is asking me to determine the amount of rice. So I'm going to let rice equal x. And then I'm going to look at the relationship between rice and liquid. 1.5 cups. 1.5 x is equal to the liquid, right? There's 1.5 times as much liquid as rice, right? 1.5 cups versus 1. I have 1 cup of rice, right? 1 cup of rice is 1.5 liquid. That's their relationship. Now, liquid, 1.5. 1.5 as a mixed number, right? 1 times 2 is 2, plus the numerator tells me the new numerator is 3 over 2. 1.5 is the same as 3 over 2, right? It might be useful to me to write that as 3 over 2 instead. It might be useful to write that. So, I use the first sentence. I haven't used this part that says, in his pantry, there was a box of vegetable stock that contained 4 cups. So I also know that liquid is equal to 4. I know that the liquid is 4. I have a relationship between liquid and rice, and I have a known value of liquid. So for my equation, I will set 4 equal to 3 halves x. I know that these must be in ratio, and x will give me the rice. It will give me the value of rice. Now, to get rid of the 3 halves in front of x, I need to divide both sides by 3 halves. I need to divide by 3 halves. Right? To cancel out 3 halves, I need to divide by 3 halves. So that'll give me x equals. Now let's do some scratch work. We have 4 divided by 3 halves.